Hey everybody, today we will do another problem, and today we will do, last time we dealt with this system, which was a balanced system. Now it's going to be unbalanced system. It's going to be unbalanced. So, unbalanced. So, it's going to be unbalanced system, which means that it's going to be a Y-to-Y connected system, but it's going to be unbalanced one, right? So we will prove that an unbalanced system, like we said last time, in order to be balanced, each line, right, corresponding to each phase, has to have the same amount of impedance, right? But unfortunately, in real life, that doesn't happen a lot, and we have to deal with unbalanced systems, and then we have to deal with situations when we have to actually, try to make it balance as much as we can, right? So in this case, it's going to be 120 volt at angle of 0 degrees over here, and it's going to be a 120, and it's going to be right here. It's going to be a 120. So it's going to be a 120 degrees right here. It's going to be at 120 volts again at 120 degrees. In this case. And right here is going to be a negative 120 degrees, so it's going to be negative. So it's going to be 120, negative 120 degrees, right? And it's going to be volts again. Okay, so assume this is the source, right? So we have a source. It's a Y-connected system, and you can actually tell that the phases are balanced, right? They have the same magnitude of voltage, and they are 120 degrees out of phase, which is should be, right? Now we have to connect a load, right? So I have to connect a load, right? So we have to connect a load. It goes like this, and it goes, drop a line down, and you have an inductor like that, right? And that is a phi j. Yes, a phi is a 5 or J5, right? And of course, it's going to be on ohms. Everything is going to be ohms, right? So ohms. And right down here, we have a resistor. Right here, we will have a resistor that comes like this, right? And then we have a capacitor. From that point, we have a capacitor going like this, right? So now, from here, we drop and then from here we drop a little bit down and it's going to be something like that, right? So So they have this point over here, C, and they have this point over here, this is capital C, and they have an A. I mean, these are not really important, so they have an A, and they have V over here. These are important, right? And this other ones, this C right here, this A, they have an A. Somewhere they have a V, capital V. They have an A here. Okay, so the resistance in this is a 10 ohms, right? Resistor. And the resisting of the impedance on this, remember, we're dealing with impedances, right? So, okay, impedance and resistance is the same. But we don't have a pure resistive load. We have inductive load and we have a capacitive load, right? So that's why we're dealing with impedances instead of resistances, right? So now, in other words, we have inductive reactance and capacitive reactance, right? That's why we're getting this. So and this is going to be minus, right? J10, which is a capacitor, and also of course this is in ohms, this is in ohms. Right. So now we have our system, right? Now we have our system. Now what we need to do now is analyze it, right? So we have a current A. Yes, we have a current A going here. So IA is going over here, right? So this current IA is going in that direction. And in this current IB is going in this direction. Okay, so we have two currents, right? Two currents, one going in this direction and the other one going in this direction, which probably is going to go in this direction, right? So we can actually do it like this, right? And then, so these two currents are going like this, right? And then they're going to the source, right? And going like this and going back and forth. That's how AC works. Now, think about this. In last problem that we have a 9 resistance in every single one of them, impedances. And in this one, we don't have that, right? We have this, and this, but they're all different. They are all different, right? So how do we deal with a system like this? Well, in this case, because we have currents, we have a transformer. Let's example a transformer, and this is an inductive and capacitive load, and it's generating, right? So, and we have a couple different loads in different phases, right? So, okay. So this is not a balanced load, right? I guess we agree with that. Now, this is the thing. We have an A going in, and then we have a current B also actually leaving the source and going to supply to the load. Leaving the source, going into the load from the main source, right? Going towards the load. So what we need to do is the following. We have to write what is called mesh current, and also mesh analysis is the one that will work better in this system. So how we start, right? So this is right here. Okay, so this is an AC signal, right? So we can start starting from here, right? Starting from here and going in this direction, right? So starting up here, going in this direction, and this right here. So let's say we're going to from plus to minus, and and then we go over here from minus to plus, and over here plus minus, right? So we go negative, we're positive to negative, negative to positive, and over here we have positive to negative, right? Okay, so how we deal with a problem like this? Well, I can start by saying that I can start by saying that this current is going up, right? So it's going from positive to a negative, right? And it's going up, so it's going like this, right? Going up, and we do 120, right? And we do angle of negative 120 degrees, right? Going up, right? Then which one is the first one I hit? I hit the negative, right? I hit the negative. So therefore it's going to be a minus 120 volts, right? So volt and minus 120 at angle 0 degrees, right? So how do I deal with this? So remember, I'm going like this, right? And I'm hitting this 5 ohm inductor, right? So I'm hitting that first. Okay, so we say that at the same time, I'm not only hitting that, I am going like this, right? And going like this, and assuming that this current goes like this, it goes like that. So I get to this, and I get to 5 plus 10, right? And then, but this is the one going in this direction, right? Now, so IA is coming in this direction. But then at the same time, I have this resistor. This resistor is also belong to IB, because IB is going in that direction. So therefore, I have to have something like this. So I get plus, right? And I get 5J, 5, J5 plus 10, right? And minus, because this is going in this direction, and that is going in this direction. They are positive each other. This one will assume that will be going like this and coming back, so it will be a negative I, negative 10 I2 equals 0. All right, so remember that I2 equal 0, right? So now having this equation, we can call this I1, right? I1 equation, right? We call that I1. Now simplifying this to the other side, I can leave only this right here, right? This, and I can subtract this sources to the other side, and I can get 5 J5, right, plus 10 minus 10 I2 is equal to that, right? Minus that is going to be negative 120 degrees, 20 volts, I'm sorry, at minus 120 degrees, right? And then plus, right? So I am adding this. So it's going to be plus 120 degrees at angle 0, right? So now, how do I simplify this, right? I need to make this, some type of simplification so I can actually work it out better. Now, what I can do what I can do is get the calculator. What I can do right here, right, is take the calculator and do this. In this calculator, what you do in this one, right? So what you do in cases like this is that you put these numbers, right? In this case, these are angles, right? So these are angles, right? So you put that into, you do second. So you put 100, negative 100, negative 120 first, right? And then you go second, and then you go complex mode, and then it's going to be an actual for angle, and you put negative 120 degrees, right? And then you put a plus in there, and then you put 120, again, that's a positive 120, and then you do second, and then you do complex, and then you do 0 degrees right there. And that will give you a number that look like this, right? So it will give you, a number that look like this. So it's going to be 5J, yeah, so J plus 10 minus 10 I2, and it's going to be equal to 180, and then plus 103.92, and it's going to be a J. Okay, so what you can do right here is the following. Instead of having like this, right? If you want to have this in the phasor domain, all you can do is convert that to a phasor domain and take the inverse tangent of that. So you take the inverse. So theta is equal to tangent inverse of 103.99, right? And then over 180, right? And that should equal to, so inverse tangent of that. So 180 is 103.9 over 180. So that is equal to 30 degrees. Right? So that is equal to 30 degrees. So theta is equal to 30 degrees. So now you can actually put that in there, right? So now you can write this as J 5 plus 10 minus 10 I2 equal to, okay, so now what you can do in this, you can find the magnitude too, right? And I think we have been doing that for a while, so I guess, the magnitude is going to be this square plus this square. Taking the square root is going to be, 29 square, and then 0 square plus 103 square. Okay, so and that is 0.9 square. Right? And that taking the square root of that is going to be equal to 207.83, right? 207.83, right? With the angle of 30 degrees. Right? So we have this equation now, right? So we have this I1 equation that we are trying to solve. Right, so that is the first Mage equation, right? Now let's do the second Mage. So the second Mage is going to be, this, right? So it's going to be, right? So we have this number, right? So the second mesh, you're going to start right here, plus 120, right? Or you're going to start at this plus 120, negative 120, go around, right? Came back, right? And remember, now we have this another one. This is going to be the one coming towards you now, so it's going to be including that that head too, right? So now, so that is, so we started at this, right? So we started at this, right? Then we go, and then we go right here. Instead of going straight up, we go like this. So we're going like this, like this, like this, and then coming back, right? So it's going to be 100. It's going to be right here. Let me just do it right here. It's going to be 120 volts, right? With the angle of 120. This is positive 120. Now I go minus 120. So minus 120, right? So minus 1. No, it's plus 120. Actually, no, it's minus because I'm hitting the minus. Yeah, I'm hitting the minus when I go here. So it's 120, and then, so I'm hitting the minus, so it's negative 120, right? So, and I'm going in this direction, so it's negative 120 at negative 120 degrees, right? And going through that, okay, I have this resistor that is 10 ohms, right? Hitting that, right? And then minus this. I'm going right here, so it's going to be 10 and minus J10, right? So it's going to be 10 and minus J10. That's correct. So it's going to be a 10. So it's going to be a 10, right? It's going to be, actually, you can put it a plus, and then plus, and then you have 10, and then you minus that J10, right? Minus that J10, right? Now, so now you still have that the little guy that is fighting against you over here, right? Right? You still have that little guy fighting against you, which is this one coming in this direction. You include this here, but you still have that guy going against you in this direction, the opposite side. So now you have minus what? Minus 10 again, that resistor, which is going to be 10, right? I1. Yeah, it's 10 I1. Yeah, 10 I1 equals 0, right? Why is I1? Because that 10 in this case is when it's coming back in this direction, that is belong to I1, right? Now simplifying this, right? Because these problems are not really easy, so you're trying to simplify as much as possible. So in this case, moving that to the other side, right? So I get 120 minus J10, and then I get 10 I1, right? Is equal to negative 120 plus 1. So right here, you gotta be careful. Be careful. You gotta put the angles in there. So in this case, it's going to be a minus negative 120, right? So that is good. This is going to be a minus, this is going to be a plus, right? So it's going to be a plus 120 angle. Actually, this is 120 positive, right? So this is 120 positive. This is 120 negative, 120, right? So now this is degrees, that is degrees. Now, when I do the math in this, doing the same thing, right? So I take those numbers in the calculator and do the same operation, right? You might have a calculator might be different, but this is what I use. So you take 120. So 120 angle of positive 120 degrees, right? And then you add to that, you add the 120. Be careful, this is a negative. Negative 120. And then angle of 120 plus 120 angle of negative 120, right? And that is equal to something like this. So that is equal to, and that is equal to 1, so that is equal to, so this part right here. So this part is going to be equal negative 207, right? Negative 207.85, right? And then okay, so basically I don't have anything else, just 207.85, right? Which in this case is point. Yeah, so that means that I don't have any angle, but it's negative, right? So what it's telling me is it's a negative 90 degrees. Yeah, so it's a 90 degree down, right? So technically this is a 90 degrees, right? Because why? Because I have, this is actually, so I get 207, right? 0.85 J, right? But remember that if I have something like this, that means I have a capacitive load and I'm going to be in the vertical direction down. So there's negative, this represents a negative 1 or negative 90 degrees, right? So with that being said, that means that this case right here, right? So yeah, so basically it's 207 angle that, right? 207 angle that, which technically is going to be 207 again, right? Angle 90 degrees, right? So it's minus, yes. So so now based on this, right? Based on this, we can say that let me just put the decimal because we're going to use those. So it's 207.85, right, at the angle of minus 9. Okay, so now we have that, right? Now what else we can do? So we have that, and we have this equation that, so we have that equation right here, right? So the next major equation is going to be I2, which is this, right? So it's going to be I2, which is 10 minus J10, right? Minus 10 I1 equal to 207.85 angle negative 90. Okay, so that is the second equation, right? So this is mesh 1. You can call it mesh. Mesh 1. You can call this mesh 2. Okay, so now that we have this, right? This is when the kind of tricky part also comes in place. Because we have this, right? So, but how do we actually solve this type of problem, right? Well, the easy way to do it, the most convenient way to do it would be by doing the method of the Cramer's rule, right? Cramer's rule, right? The matrices method. So we have this and we have this. So the Cramer's rule tell us that A, so it's going to be, so I1, for example, I1 is going to be equal to delta 1 over delta. So, and delta is what is called the discriminating, right? I guess it's okay. So I guess this guy is discriminating, right? Anyway, but okay, so I don't know. That's odd how they came out with terms. Okay, so this is the discriminant. This one is the product. It's acting almost like the discriminant, but in a different. Yeah, I guess you would say they're kind of different, you know. So this guy right here is the product of this with part of this, and I will do it right here. So I will just put this 5, right? So okay, so this is, let's say for example that this equation, so let's say for example that this is A1, B1, A2, B2, right? And then this is equal to C1 and C2. As you can see that I have it two different, right? Let me just put it like this. This guy is belong to this guy, and this guy is belong to this guy. Right. Now, so how do we deal with something like this, right? So, okay. So let's all right. So let's put this. Let's put this in this equation. So let's do this one, which is going to be J5 plus 10, right? Minus 10, right? I just put the coefficient of this, right? Of course, this is a complex number. I got to put the whole thing. And then right here at the bottom, I gotta put 10 minus J10. And then of course, this is a minus 10. And then in this side, I get what? I get 207, 207. I get 207, 207, 207.85 angle 30 degrees. And here I get 207.85 angled minus 90. Okay, so when I do that, right? So actually, I guess it doesn't matter, but it's good to have them. So it's 10 plus J5. I guess they want to keep things in order. This is like a resistor before the inductive or capacitive impedance, I guess. Right, so when we do this, right, we get this, right? So this is 10 plus J5, right? And I'm going to multiply this times this minus this times this, right? So it's going to be 10 minus J10, right? And then I'm going to do, right here, I'm going to do negative 10 times negative 10. Okay, so when I do this, right, so I get this times this is 100, right? And this time this is 100. It's going to be 100 J, right? Then this times this is going to be plus 50 plus J50, right? And this time this is going to be minus J squared 50, right? This times this. And of course it's going to be this time this is going to be 100, right? I put in brackets, so that let me know that this is the still positive number is going to be being subtracted from this. So when I add those two, I get 100 negative J50, right? Negative J50 minus, right? Minus a negative 1, right? Times 50, right? J squared is equal to negative 1, and that is minus 100. Okay, so I get 100 minus J50, right? Plus 50, right? Minus 100, right? I subtract that, right? So now adding this and this is equal to, that is adding this and this, right? It's going to be negative 50, so it's going to be 100 minus J50 minus 50, right? And then adding this and this is going to be 50 J negative, right? This is negative J50. So okay, so that is right. So how do we actually do it simpler? So you take that, so it's going to be 50 squared plus 50 squared, right? So so 50 squared plus 50 squared, right? And you take the square root of that, it's 70 70.71, right? And with an angle of, in this case, so it's the same. So it's going to be negative 45 degrees, right? Take the inverse tangent of those. Inverse tangent of that is going to be negative 45 degrees. So that is the first. So that is our delta, 70.71, angle of negative 45 degrees, right? Okay, so we have that. Now we found the first, right? The first part that we have for that equation. Now, so let's say that this I1, right? So you're trying to calculate I1, which is, or IA, that is going in this direction. Okay, so with that being said, that means that we have to do the rest, right? And we have not done anything with this. So what we can do is replace, right? So now what we can say is replace these guys in one of this and call it that delta A, delta 1, I'm sorry, is equal to, normally we call this E and E, and they call it this F. So, so what I will say is AF minus EB. So AF minus EB. So, okay, minus B. So what did that mean? That means that I have to replace this by this guy, right? And then I have to do that for A1, and then for A2, I have to replace this guy with this guy, right? So let's do that right now. So let's replace this, right? So I'm going to have something like this. So I'm going to have something like this. So I'm going to have this over here, and I'm going to have 107.85 angle 30 degrees. 207.85 angle 90 degrees, right? And I should have minus 10 here. And I should have minus 10 minus, okay, 10 minus J10 here, right? So, all right, so let's knock those out and see what we get. So, if you take the calculator, right? So you can do it by hand. You can convert this to rectangular, and you can do all this bunch of math. But okay, so let's do 207.85, right? This times this minus this times this. Right. So then I do angle, angle, and then I do this times this, right? And I do 30 degrees, right? And I multiply that by 10 minus 10 minus 10 right? So it's equal to 28. So this gives me this, right? Gives the, want to make sure you guys understand this. This one gets very hairy. You start doing this stuff by hand. So this, right, minus that, right? So in this case, I have it that, right? So, and I got it that this one gave me 28, 29, right? And then minus 760. I think it's 0.92 I. This, right? Remember this. So I am doing AF now. Now, I gotta do this, right? I gotta do this. So when I do that, I get 207.85. And then I do angle, right? And I do angle of negative 90. And I multiply that by negative 10. Okay, and this is equal to minus, and I will put right here in bracket, that is equal to 28.7. So 28.78. 28.78.5 J. 0.5 J. Okay, so now when you add this to this, right? Because you don't have nothing else to add, but remember, that will become a negative, right? So then it's going to be equal to what? It's going to be 28.39, right? Minus 7.609, right? 9.9. That too doesn't really matter. J, right? And it's going to be 27.89. Actually, 8.78, right? Don't worry about the 0.5. So, all right, so if I add that to that, right, I get 7. So I do 760 plus 20878 is equal to 21. So it's equal to 21638, right? But so this right here, so this is negative and this is J, right? And then right here we have 28.39. Okay, so if I take that, right? So if I take that and square it plus 28, 29 square, right? So, okay, let me do this again. Let me do this again. Let me do this again. Right, so I am doing, this time is this. All right, so right here I'm doing this times that, right? So let me just do that again. So 207.58. Second angle of minus 90 degrees times negative 10. 27.8. So I don't know why I wrote that. It's 20, 27, 78. Right. And this is, of course, this is right? When I add this two, I add 27, 27, 8, 27, 8 plus 760, right? Is equal to, this equal to, so this is going to, when I add those two, it's going to be 2839 minus 2838 minus 2838. So when I do that, so I do that squared plus 2839 squared. And I get that is about so it's about, for some reason I got very close to 4085.5.6, right? Because I've been taking out some numbers, right? But basically it's pretty close. It's very close to the numbers that. Okay, so now if we have that, right? So actually, this was very close to 29. This was very close to 29. So basically it was like, so let me just make that 39. Because if I don't do that, I'm not going to get 45-degree angle, which is fine. The ends are not going to change by a lot. So, but just do it out of that. So 2839 squared plus, and then so right. So now I got so this. So now I am doing A1. So or delta 1, right? So which is going to be equal to, 40, A0, angle of negative 45 degrees. All right. So now, if I take that number, right, I get divided by 71.70. It's equal to very close to 57, very close to 57. So A1, right? So now, okay, so never mind. So let's leave it as it is for now. I don't want to confuse people, right? They just do it step by step. So I have this, right? Matter of fact, it's 79, but like I said, so not gonna make a huge difference, right? So now I have this, right? How I found A1, right? Now I gotta find I1, which is equal to that divided by that, right? So it's going to be 4079 over that, right? So 70.71, which is going to be equal to an angle of 45. Okay, so I got to include the angles over here. So this is an angle of negative 45 degrees. This is an angle of 30 degrees, right? So when I move that up, right? When I move this up, this becomes I1, right? And that is equal to 60, around 56.9, right? Amps. 56.9 amps. Angle of, right? 56.9 amps at an angle of, when I bring this up here, so it's going to be this one is going to be minus an angle of 75 degrees, right? So at that point, it's going to be an angle of, actually, wait a second, no, this was 45 degrees. 45 degrees, this is 45 degrees. So if this is 45 degrees, when I bring it up, that is 0, right? So that is 0. So the angle right there is 0, which is technically 56.9 amps. Okay, so now we have the first current, right? We have the first current. Now, we do the same thing. We do exactly the same thing, but now we will moving these items in this, right? So now this is going to be taking care of this, and we will have this. So let's do it. So we have I1 is equal to 56.9 amps. Right. That's I1. I1. Let's do I2. Right. So I2, we replacing this guy. So I2, we do we're replacing um, this guy right here. So it's going to be 10 plus 5j, right? Now we will have a 10 here, negative 10. And over here we'll have a 207.85 angle of 30 degrees, right? And over here we will have a 207.85 angle of 90 degrees, negative. When we do that, right, we do this math, we get 10 plus 5, right? So we do 10 plus 5 plus 5j, right? And then we multiply that by this guy, right? So 207.85, right? And then an angle of 90 degrees. Right, so that is going to be that one, and it's going to be equal to 1039, right? 1039 minus 2078J. I am doing a lot of decimals, skipping here. That's why probably is going. If you do it with all the decimals, you will get like maybe little slight difference in the answer. But okay, so I not include the decimals. Okay, so I have that right for this. Now I gotta do this and this, right? So now I do that, and then I do what? I do minus negative 10. Negative 10, right? And I am doing this. So minus negative 10 times 207.85 second angle of 30 degrees. Right? So then that is equal to, this is equal to, right? So this is equal to, when I do that, right? So that is equal to, this is equal to, actually when I do the whole thing, right? But let me just step by step. But in the whole thing, I get 2839, right? Point a decimal again, I'm gonna do that, and I get the minus 1039J. Okay, that's in total, right? Total. Now, but let me see how this works, right? So you actually see. So right here, when I do that, when I do negative 10, right? And then I multiply that times this, which is 207.85. And I do an angle of, so negative 10 times 207.85 second in an angle of 30 degrees, right? This part right here. So I want to make sure you guys understand this. So if I do that, this is going to be equal to negative 1800, right? Plus, and then a negative 1029, right? Negative 1029. So now, when we do that, right? We get, so we get that this one right here, right? So I get this, and that is going to give me, so I get 1039 plus, because this is going to be a positive, this is going to be a positive too, right? So 1039, right? 1039 plus 1800 is going to be this guy right here, right? So I want to make it sure that you get this. So it's going to be 2829, right? And this. Now this one becomes a positive, that one becomes a positive, and when you add this and this, you will get, yeah. So as I was saying before my camera started messing up, that if you add this, right? So by adding this and this, you get this, right? By adding this and this, you get this, right? So if you add this right here, right, which is a J, right? So you can put it in the calculator. You do negative 20.78, right? So, I mean, you can do it, but in your head too. I mean, it's, just the half, right? Plus 1039, right? It's equal to negative, it's equal to this guy right here. Okay, so now what we can do right here is find the magnitude of that, right? So remember that now this is A2 actually, right? Because we found A1, right? Now it's going to be A2, right? So A2 or alpha, delta 2, right? In this case, delta 2, it's going to be equal to the magnitude of that, which is going to be equal to 2839 squared, right? Plus, right? And I'm saying plus, this is negative, but it doesn't matter. When you square, it's going to be a plus, right? So it's going to be 1029 squared, right? So when you do that, right, it's going to be equal to square that plus 2829 squared. So that is going to be equal to 991,913,942, right? And then you take the square root of that, and it's equal to about 3023, right? And then again, I'm not gonna put the decimals on it. So and then the angle of that, right? The angle of this is going to be inverse tangent of of negative 1039 over 2839 is equal to 20 is equal to a negative 20 degrees, right? Again, with decimals, I'm not going to worry about that, right? So I want to make sure that if you get different answers, just make it, yeah. So don't get surprised if your answer is going to be slightly different than this, because I'm not counting the decimals. Okay, so this one, so this is basically A2 now, right? So now we take this A2, so we found I2, right? By doing A2, or alpha, delta 2 over delta, right? So 2 is going to be equal to what? So I2 is going to be equal to, right? So now I have this, right? So I have this. This guy is the angle for that. So it's going to be, matter of fact, you know what? Let me just do it. Let me just clear some space. So where do I want to do that? Let's see. Do I want to do it? I guess I can do it here. So okay, so in this case, right? So what I can do is just, we know what the formula is right now. So I can clear that. And I can say that this one is 32.3 angle of negative 20 degrees, right? It's going to be divided by that guy, which is going to be 70.71. And it's going to be angle of negative 45 degrees, right? So when I do that, the math, it's going to be, so when I do that, it's going to be 32.3, right? It's going to be divided by 7.71. It's going to be 42. About 42. It's going to be about 42. It's 42.75. Again, I did not count the decimals, so I will say 43 amps, right? Because this is, technically that is 42.75, right? But just round it up, right? 43 amps, right? Now the angle over here is going to change because that is going to add up over here, right? So that angle, in this case, is going to be, if I add up to the top, it's going to be 25 degrees, right? So it's going to be, equal to 25 degrees, right? As you can see now that the currents are different, right? And that's the whole point about this, right? That is the whole point about this. This current, you can see, it is a big difference, right? It is a big difference. Now, so you're talking about a difference of, you're talking about a difference of almost 15 amps. So you're talking about a difference almost 15 amps. So that is a lot. That is a lot, actually. And so that is a lot. And you can see that the first one we didn't get an angle, the second one we got an angle, right? So you can see that this one and this one are a difference. So therefore, this is the whole point of this video, to prove that we have an imbalanced load, right? And even though, and this is a very, very important point to understand, even though this these loads that are over here are coming in, right? From this different, from the same source, right? Technically, this is not the same node, and I want to repeat this myself again. These are different, right? This, just because this medium right there, and I can actually pull out a neutral, that's the whole purpose of having a balanced load, that the excess current, the difference is going to be going through the neutral, going back to the source. So let's say if I put a neutral here, right? So the difference, those 15 amps, almost 15 amps of difference are going to flow in the neutral, right? But just because this is trying to balance it out, right, to make it equal zero, because Kirchhoff's law, that's what tells us. But the bottom line is this one is not one node, like in one node. This is like three different branch circuits coming out of this, right? We can actually prove that if you go back here, right, it's one. If you go this source, it's another one, and this source is another one. So like a three different branch circuits in one system. Now, when you load, when the loads are different, in these lines, when the loads are different in this line, it creates an imbalanced load, and it's when we start having problems. So, imbalanced load. Unfortunately, in the real world, we have to deal with imbalanced load, but as long as not, to an excess, it's fine. But anyway, that's the whole point of doing this video about the difference between balanced and imbalanced loads. We can actually prove that the difference over here was about very close to 15 amps. Actually, yeah, pretty close. I mean, if I do 43 even, if I do, let's say, for example, if I round it up to 57, right? So 57, right? 57 amps, right? And then and the other one, and the other one is 43, right? So it's 14 amps, right? So 14 amps of difference. That's a lot. That's a lot amperage. So this is what what make an imbalanced load. The difference in current, right? The voltage, for the most part, is balanced. But if I have a neutral like this coming out here, a neutral, that will be compensated for that. And that's why you don't want to mess with the neutral. If there is a load, you don't want to touch the neutral, because you will get sad. Because if the current is imbalanced and that the neutral, when there is a load, that current will go back to the source. If you touch the neutral and you grab into something that is conductive, you will be in deep trouble. So you don't want to do that. So be careful with electricity. It's very dangerous. So that's what I'm trying to say over here, that imbalanced loads are created because imbalanced resistances. And think about it. Let's say, for example, you have over here in this phase, which is this is phase, this is line, right? But then you have in this line you have whatever, you got 50 motors, right? And then in this side right here you will have and then in this line you will have 20 motors. And then in this one you will have 8. So it's going to be different currents. Why? Because you will add it up to different resistances and will create a problem similar to this. When we have a difference of about 14 amps in current, and that is going to be creating, and then if you do the math, it's going to be the angle is going to be affected, the power factor is going to be affected because the power factor depends on the phase angle. So it's going to create a lot of problems. So when you have imbalance, a lot of imbalance load usually affects the power factor. Thank you for watching, and I see you in the next video.